Hello and welcome back. In this video we'll cover inverse trig functions and this will be just one video on the subject and this will be useful from here on out. Inverse trig functions effectively undo the usual trig functions, and when I say undo, if you're given an angle and we know that the sine of the angle is equal to A, the question is, can I figure out the angle? Do I know what the angle was to begin with? Well, we can use the inverse trig function, which is often written as arc sine. So for instance, if the sine of theta is equal to A, the arc sine of A is equal to theta. In the same way that exponential functions and logarithms undo one another, sine and arc sine undo one another. You will often see this written as inverse sine, with the -1 right there as well. So the arc sine and inverse sine are exactly the same thing. It's just different ways of writing it down. So likewise, if I know that the cosine of theta is equal to A, the arc cosine of A is equal to theta. And then again, I can write it as the inverse cosine of A. And then the same thing with tangent. We have tangent of theta, or we can have the arctangent of A. And again, we can write this as the inverse tangent of A is equal to theta. So let's see this in practice. And as a brief reminder, I want to say that this only works if your angles are going to be between 0 and 90, and I'll briefly touch on what happens if our angles are not between 0 and 90 in a little bit. But for the moment, let's just talk about acute angles. So acute angles between 0 degrees and 90 degrees. And if we know that the sine of an angle is going to be 0.29, the question is what is theta? What angle has a sine equal to 0.29? So let's come to let's use a calculator. I'll use Desmos. It's quite a nice calculator. And what we'll see is that we don't have an inverse sine function in the usual functions here. So if we come over to functions, though, we have inverse sine or arc sine right here. So the inverse sine of 0.29 close parenthesis, and that's going to be 16 point, let's round this to 86. So going back here, we know that, so let me show you my steps. We know that the sine of theta is equal to 0.29. Well, this means that the arc sine of 0.29 is equal to theta. So again, in order to get the theta out of the sine, I use the inverse sine function, and we found that that was 16.86 degrees. And notice that we wanted it to be acute, and our answer here is acute. This is an acute angle. So let's look at the next one. If theta is an acute angle and cosine is going to be 0.9, what is theta? Well, again, if we know that the cosine of theta is going to be equal to 0.9, then the arc cosine of 0.9 is equal to theta. It allows us to switch the position of those guys. So I can just pull up my calculator again and type in the inverse cosine of 0.9, and that should give me theta. So again, no inverse cosine here, but in the functions tab, yeah, we have the inverse cosine of 0.9, and that is equal to 25.84. So let's type that in. And so we've got theta is equal to 25.84? I've already forgotten. Yes. And again, what you'll notice is that we wanted our angle to be acute, and our angle is indeed between 0 and 90 degrees. So everything's good. So what about angles that aren't just acute angles? And when we're looking at angles, there are different angles that can have the same sign, as in the same sine value, the same cosine, or even the same tangent value. So here's an example. Let's take two angles, and I'm looking at the point xy, and this distance here is going to be r. So the distance from the origin to that point is going to be r. And I can look at this angle right here. So the sine of that angle is going to be y divided by r, which is all well and good until we look over here. And when we look at the point negative xy, as in whatever x value this was at, if there is x, on the other side I can look for negative x, but they're both at the same height, and they're both the same distance away from the origin. So it's as if I flipped this over, and I've just moved this point to the other side. What happens here? Well, I have this other angle, so maybe I'll call that angle theta 1, and I'll call this angle theta 2. So what is the sine of theta 2? Well, it's the y value, which they have the same y value, and they're the same distance away from the origin. So both of these guys are equal to one another. So the sine of theta 1 is in fact equal to the sine of theta 2. But how does my arc sine? My arc sine should cancel out that sine function, right? Well, the range of arc sine is angles between negative 90 degrees and 90 degrees. So if I wanted to take the arc sine of the sine of this angle, it's only going to spit out an angle between negative 90 degrees and 90 degrees. So, for instance, right here, since theta 1 is between 0 degrees and 90 degrees, it's in quadrant 1, if I take arc sine of theta 1, I'm going to get theta 1, because sine and arc sine will cancel out, and arc sine is going to spit out an angle between 0 and 90 degrees. But if I take arc sine of the sine of theta 2, I'm also going to get theta 1. And again, this is because arc sine only spits out angles between negative 90 degrees and 90 degrees. Theta 2, this long angle, is going to be between, 180 degrees and 90 degrees. Arc sine will never spit out an angle over there. So the question is, if I know that I have this angle, if I know that I have theta 2, how can I possibly know what to do here? How could I get theta 2? And the nice trick is the following. What is the relationship between theta 1 and theta 2? Well, if we look closely, this angle over here between the negative x-axis and this line is also theta 1. So if I start from the positive x-axis and come all the way over here, we'll see that theta 1 plus theta 2 is 180 degrees. Or in other words, if I know theta 1, I can figure out theta 2 by taking 180 degrees minus theta 1. So let's do an example. Let's say that theta is an obtuse angle, so it's between 0 and it's between 90 degrees and 180 degrees. It opens more than a right angle. And we know that the sine of that angle is 0.29. What is theta? Well, I might start this by going, okay, I know that the sine of theta is equal to 0.29, and this should mean that I want to take the arc sine, right? I want to take the arc sine of 0.29 to get theta. Well, we saw before that the arc sine of 0.29 is 16.86 degrees. So theta is equal to 16.86 degrees. Well, no, because we know that this angle should be obtuse. It should be between 90 degrees and 180 degrees. So we're up here in this situation. We have this theta 1 in here, but we don't want theta 1 because it's an acute angle. We want theta 2. They both have the same sign. They both have the same value for the sine function. So we find the obtuse angle by taking 180 degrees minus that. So the answer is no, this isn't what I want. Theta is in fact equal to 180 degrees minus 16.86 degrees, which, if I do the math, I should get 163.14 degrees. So this is an acute angle, or sorry, an obtuse angle. It's between 180 degrees and 90 degrees. So here's my answer. I am primarily going to focus on angles that show up in triangles. And in a triangle, we might have acute angles, we might have right angles, and we might have obtuse angles. So all of our angles are either going to be between 0 and 90 degrees, or between 90 and 180 degrees. And so for the sine function, we have to be a little bit careful. Cosine, on the other hand, everything is good. The arc cosine will spit out angles between 0 and 180 degrees, so we don't have to do any tricks with arc cosine. The only thing that we have to worry about is arc sine. If we want an obtuse angle, we're going to have to take 180 minus that angle. And I'll do some more examples where this shows up in the next video.